Hi everyone, this is Jagjit and today we're going to be going over chain rule. So let's say if we have an equation y is f of g of x, okay? Y is made up of a function f, which is further made up of g of x, okay? So our derivative is just going to be derivative of f times derivative of n side, okay? I know at this point it probably doesn't make much of a sense, but when we do a few examples, it's gonna sink in, okay? So let's get into the examples, folks. We're gonna get into the examples. So my f of x is 4x squared minus 3x minus 9 raised to the power 12, okay? We want to get the derivative of that. So again, same as power rule. Whenever we have a power at the top, we're going to times it by the constant in front, which is just going to be 12. And now the power is going to go down by 1. The power is going to get subtracted by 1, so this would just be 11. Times, so this is where the chain rule comes in, times derivative of n side. So derivative of this whole thing is going to be 8x minus 3, okay? I'm not going to solve this further because I just want to make sure you understand the concept first, okay? F of x was 4x squared minus 3x minus 9, all raised to the power 12, okay? To get the derivative, we will do 12 times constant in front, which is 1. So 12 times 1 is 12. And now the power goes down by 1. So that just becomes 11 times derivative of n side, which is going to be 8x minus 3, okay? Let's do another example. So if I have f of x is square root of 7x squared plus 9, okay? We're going to first write this as the exponent. So it's going to be 7x squared plus 9 raised to the power 1 over 2. To get the derivative, the exponent is going to multiply with the constant in front, which is 1 over 2. And now you're going to subtract 1 from the power. So that would be 7x squared plus 9 raised to the power minus 1 over 2 times derivative of the n side, guys. So derivative of n side is just going to be 14x, okay? It's very important that we do that. Now, this was a negative exponent, so we're just going to move it to the bottom, and that would become positive 1 over 2, which is just square root of 7x squared plus 9 times 14x. Then we can divide 14 by 2, so you got 7x at the top, and at the bottom you got square root of 7x squared plus 9. Okay? We're going to do a couple more examples. Next up, we have f of x is equal to 3x plus 1 over 3x minus 1 all raised to the power 5. Okay? F of x is equal to 3x plus 1 divided by 3x minus 1 all raised to the power 5. We're going to get the derivative. So this will just be power times the number in front, which is 5. And now the powers are going to go down by 1, so it's just going to be 3x plus 1 over 3x minus 1 all raised to the power 4. But we're not done yet, folks. Times derivative of the n side. Now, in order to get the derivative of the n side, we need to use quotient rule. So that's just going to be derivative of the top term, which is 3, times your bottom term, minus derivative of the bottom term, which is 3, times your top term. All divided by your bottom term whole square. So it's just going to be 3x minus 1 whole square. We're going to FOIL this, folks. So let's separate these terms. So we got 5 times 3x plus 1 raised to the power 4 over 3x minus 1 raised to the power 4. And now this would just become 3 times 3x is 9x. And we see over there we're going to get minus 9x. So 9x minus 9x is going to cancel. To show it to you, I'm going to just FOIL it. 3 times 3x is 9x. 3 times minus 1 is minus 3. Now we have minus 3 times 3x is minus 9x, and minus 3 times 1 is minus 3. All over 3x minus 1 whole square. So we get 9x minus 9x, that cancels, and minus 3 is going to be minus 6. So we got minus 6 over there. Minus 6 times 5 is going to give me minus 30. We have 3x plus 1 raised to the power 4 over 3x minus 1 raised to the power 4. And we also have 3x minus 1 raised to the power squared term over there. So straight away, we can combine these two terms, and that would just be minus 30 times 3x plus 1 raised to the power 4 divided by 3x minus 1 raised to the power 6. And that's our final answer for this question. Okay, guys, this is a very good example. I want you to practice this a few times, okay? Let's carry on. So we have f of x is equal to 5 over x squared plus 9. Now guys, we did this question using quotient rule early on, but we can easily do this using chain rule. Okay, let's move this term to the top. X squared plus 9, when it moves to the top, it's going to become x squared plus 9 raised to the power minus 1. Okay, now when we get the derivative, it's just going to be minus 1 times 5, which is minus 5. And now the power is going to go down by 1. So it becomes minus 2 times derivative of the inside, which is just 2x. Okay? So that's going to be minus 5 times 2x, which is minus 10x. And we're going to move this term to the bottom. So the exponent is now going to become positive. So that's our derivative using chain rule. Okay? Let's do another example. So in the next question, we have f of x is equal to cube root of 5x squared minus 2x plus 1. As a first step, we're going to change this cube root to exponent. So it's just going to be 5x squared minus 2x plus 1, all raised to the power 1 over 3. Cube root can be written as raised to the power 1 over 3. And now we're going to get the derivative, folks. So we'll do power times the number in front, which is just 1 over 3. And now the power is going to go down by 1. So we'll have 1 over 3 minus 1, which can be thought of as 1 over 3 minus 3 over 3, which is going to give me minus 2 over 3 as the exponent, times derivative of inside, which is going to be 10x minus 2. So in the next step, we're just going to move this term to the bottom. So we'll have 10x minus 2 at the top. And at the bottom, we're going to move this, and this will just become a positive power, a positive exponent, 2 over 3. Okay? So that's our final answer for the derivative of that equation. Let's do another example, folks. F of x is equal to square root of 1 plus x squared minus 1 cube. Okay, in the first step, we're going to change this root to an exponent. So it will just be raised to the power 1 over 2. Okay, we're going to get the derivative by doing power times the number in front, which is 1 over 2. And now that whole thing, its power is going to go down by 1. So 1 over 2 minus 1 will give you minus 1 over 2 times derivative of the inside. Now, this is just going to be 0. But to get the derivative of this, we're going to have to use chain rule again, once more. So derivative of that, the 3 is going to come in front. Power is going to go down by 1. This becomes 2 times derivative of inside, which is just going to be 2x. Okay, this is the tricky question. So now in the next step, we're just going to move this term to the bottom, and it'll become positive 1 over 2. We're just going to write it as a square root. Okay? So we have 2, and we're going to put a square root and write that term over there. And 3 times 2x is 6x times x squared minus 1 whole square. Okay? In the next step, we can do 6x divided by 2. That's just going to be 3x at the top times x squared minus 1 whole square divided by square root of 1 plus x squared minus 1 cube. And that's my final answer for the derivative of this equation. This is a good example. Make sure you practice this a few times, folks. Okay? All right, folks, final question. We have 1 over x cubed plus e squared. Okay, we're going to move this term to the top. So this becomes x cubed plus e raised to the power minus 2. Now we're going to get the derivative. Power times the number in front, which gives me minus 2. And now you're going to subtract it by 1. So that gives me minus 3 times derivative of inside. Now derivative of x cubed is just 3x squared. And e is just a constant, folks. Don't get confused over e. E is just a constant, and derivative of the constant is just 0. So this is just going to be 3x squared. So this is going to be minus 2 times 3x squared, which is minus 6x squared. We're going to bring this term to the bottom. And we have x cubed plus e raised to the power 3. And that's my final answer for the derivative. Okay? Hope you guys have a good understanding of chain rule by now, folks. Thank you very much.